Alright, let's see if this makes any sense. We're in section 1.2, we're working on problem 1.2a, and we're doing items 1a through g. We just talked about 1a with the domain and range, and there's no limit on those. We can take a look at f of 3, and what does that equal? When, let me get the equation back up here, f of x is equal to 1.5x minus 4. So if f of 3 is what we're testing, then we simply take f of 3 is equal to 1.5 times 3 minus 4. So 1.5 times 3 is 4.5 minus 4. 4.5 minus 4 is 0.5. So f of 3 is equal to 0.5. Again, at this point, the only thing that's new is should be using this f of this function notation. So item B, which we just finished, item C, same thing, you just have a negative number. Item D, however, we say f of what is equal to 5. And here you would treat this just like you would all the other problems before, where you'd say 5 is equal to 1.5x minus 4. You'd follow your algebra, and you'd have 9 is equal to 1.5x. So I think that should be pretty straightforward there. However, if we take a look at item number F, we see something a little different. I know you've done some problems like this before. Let me erase and we'll work on that one. So now if we work on item F, item F, it says f of n equals what? Well, this, you treat it exactly the same way as if you had f of 2 or f of 3. You simply take your original statement, f of x equals 1.5x minus 4, and n is now your value, so you replace your variable x with the variable n wherever it is. So, your answer, f of n, is equal to 1.5n minus 4, and I only rewrote it because the parentheses are not necessary in this case. So f of n is equal to 1.5n minus 4. Use the same concept now when we take a look at item G. I'll erase this and we'll work on G. So for item G, we have f of x plus 1 equals what? So here we do the exact same thing. We take our equation equals 1.5 times, you take everything that's in the parenthesis and replace it in every place there is an x. You put the whole thing in there, minus 4. So now we have f of x plus 1 is equal to 1.5 times x plus 1 minus 4. So if we do our algebra, f of x plus 1 is equal to 1.5. You do your distribution, 1.5x, 1.5 times positive 1 is plus 1.5. Now you're done distributing, minus 4. 1.5 can't combine with anything on that side, so we keep it. 1.5 minus should be a negative 2.5. So f of x plus 1 is equal to 1.5x minus 2.5. Again, with this function notation, you can see your domain value and you can see your range all in the simple notation right there. Now we're going to move to item 2, and we'll start to see now a difference between the domain and range that's possible to go in. Okay, so this one we're going to work on 1.2a, problem number 2, A through F. And for item number A, it asks, suppose g of x, that's just some function g that is in terms of x, suppose that it is defined by the square root of x. What are the domain and range of g of x? So if we think of domain refers to your input variable, which refers to x. What values can you put here in the domain? Well, maybe the question is, what values of x can you not put? We know that 0 is okay in there. We know that positive numbers are okay. But what about negative numbers? Yeah, those don't work. You can't take the square root of a negative number at this point. So your domain would look something like the timeline 0, or not timeline, the number line, where x is greater than or equal to 0. That is your domain. Your domain would be numbers where x is greater than or equal to 0. Likewise, if you put in the value of 0 for x, what's the square root of 0? That's 0. If you put in the number 4 in for x, the square root of x, square root of 4 is 2. So you can't get anything less than. So your range or your output is going to be all numbers also greater than or equal to 0. So that's how you would answer A. B, you should be able to do B, you should be able to do C. We'll take a look at D. So if we're starting with the function g of x is equal to the square root of x, item number D is saying the g of what is equal to 5. So it's wanting to know what domain value do we put in if we're getting out a 5. So easy enough to take this, set this equal to the square root of x, and following your algebra, if you need to get rid of the radical, which is a square root, you would square both sides of the equation. So you'd get 25 equal to x. And you square it, you get one value. So now we know that x is 25. So we come back here and we can say the g of 25 is equal to 5. The only difference that we're doing here is simply using this notation to replace y. That's all it is. Now, if we step forward to item F in that section 2, we have the equation g of x minus 5 equals what? Well, again, we know that this is what our function is. So g of x minus 5 is equal to the square root of, and using this notation, everything that's in here replaces everything that's represented in the variable x. So we'd say the square root of x minus 5. Well, in this case, there's actually not a lot more that we can do with that. So the g of x minus 5 is the square root of x minus 5. So we're stuck there. That's the end of it. There's really nothing more to simplify. So I think that's enough now for section 1.2. You can go ahead and finish 1.2a3 and 1.2b and 1.2c if you want. We'll call that good for now.